In this video we're going to take a look at the Tree of Danger challenge, which is a medium miscellaneous challenge, and the description says, as you approach SafetyCorp's headquarters, you come across an enormous cogwork tree. As you watch, a mechanical snake slithers out of a valve, inspecting you carefully. Can you build a disguise and slip past it? So this challenge was actually part of the HackTheBox University qualifiers that ran a week or two ago, and it went straight into the retired section along with some of the other challenges, although there's been some slight changes to some of them. I think some of the challenges with low solves went into the active category as well, so we can't do any walkthroughs on those. Also, disclaimer, before I attempted this challenge, I'd already seen some write-ups from the HackTheBox University qualifiers, so how to solve the challenge and some different techniques and stuff was already kind of known to me, but I've got the files downloaded for this. We've got a server up and running because we need to run the exploit against the remote server once we've got things working locally, or once we've explored it locally. But let's go and take a look at the files. So I'm going to open up the Python script we have here. We have this util.py. I'm going to open that up. That's all we had to look at. I'm opening this up in Codium so we can have a look at the code. Note that this is set to use Python 3.10, which I don't actually have installed, and due to the amount of problems I have with Python installations on Parrot, I didn't bother trying to install it. So I'm just going to run through this code and then we'll test things out against the remote server. So let's start off at this main function where we know the program's going to start. It's going to print out this welcome message to us, and it's going to take some input from us in this x variable. It's then going to call this function isSafe, which we can see here, and isSafe is going to check to see if there's any, it's saying bad in this character, so it's basically checking to see if there's any underscores in the expression which has been passed to it, and if there is, it's going to return false. So basically we can't have any underscores in our input. It's then going to call this isExpressionSafe and do this AST abstract syntax tree parse, which we'll look at in a bit more detail in a second, but essentially this is checking to make sure this is safe before it'll then try to eval the statement that we provide. You can see that our user input is going to be evaled here, which is never good. We know that if this program, it doesn't import OS, but if this was to import OS, we could do quite simply here just use OS to call system and cat the flag or get a shell or something like that. But we also have this additional stuff in here which is being passed in. We have math. Let me just highlight that eval. So you can, if you have Codium syntax highlighting, you can just highlight the functions here and see exactly what they're doing and what the parameters will be. We can see this is bringing in maths. It's setting the built-ins to be empty so that we can't access the built-ins, and then we have this get attra function which is being passed in as well. Let's go and have a look at a bit more detail of the isExpressionSafe, because we know that we can't put in any underscores, which is potentially going to be an issue for us, because you can see here we have underscores in things like the built-ins and import and other things that we might want to use within Python. Essentially, even without the access to the built-ins, we can pivot from libraries in, if we have access to this eval statement, we can pivot and access classes and subclasses and things like that, and pivot to other libraries and functions to achieve our goal. Yeah, let's go and have a look at this isExpressionSafe anyway, so we can see it's passing in, it's doing AST parse. Again, you could highlight this and have a look exactly what this is doing. It's parsing the source into an AST node, equivalent to, etc. Let's go and take a look at it. So we have a match statement here. It's running through these different possible cases, and it's testing the node which is passed in. First of all, it's going to see if it's a constant, so if it's a string or you can see here highlighting that as well. If it's a string or if it's an integer or a float or something like that, it's just going to return true because that's safe. There's no worries about passing a integer to eval. If it's a list or a tuple or a set, it's going to send it to this isSequenceSafe function, which is essentially, so this is going to kind of run recursively. So this is going through, it's grabbing all of the node elements. So if this is a tree of nodes, it's then going to go through and recursively call isSequenceSafe. You can see here, isExpressionSafe, which is this function again. So it'll go through, it'll take that node in, it'll get all the node's elements, and then it'll pass those back through to this isExpressionSafe. And it'll keep doing that to make sure basically every part of this syntax tree is safe. So that'll deal with the list of tuples and sets. We also have dictionaries as well, so we have another function called isDictSafe, which again is going to do something kind of similar. It's getting the keys and the values from the tree, and it's going to call isExpressionSafe, which is again this function here recursively. We'll have another look at this function in a second. Let's just keep going through this case statement. We have this unary operator, which is an operator that only has one operand, I believe. So something like if you're saying I++ or I minus or something, one of these kind of functions, and essentially it's just going to grab the operand, it's going to pass it back through to this function recursively. We have a binary operator, so this would be if we have, you can see here, left operator then right. So if we had something like A plus B. Also, because this is recursive, as you can see here, it's running recursively. So if we had something like, let me do here, A plus B minus C plus D. So this would be our left node, this would be our right, and it would go and this would be our operand in the middle. So then it would pass this left node back to isExpressionSafe. It'd do the same with this one as well, and then that would be two more binary operators. So then it would do the same thing there, and then it would check each one of those nodes and keep going through that recursively. We also have this call as well. So if it's a function call, it's going to go to isCallSafe, another kind of custom function that we have here. We have this isExpressionSafe is being called again, so you can see very recursive. And the arguments to the function and stuff as well are going to be sent through to that. And then we have our attribute here as well, which is just taking the node value. So if you have a node, it can have a value inside it. Basically, that'll just be passed back through to this function. And then finally, it'll return false. So that's the isExpressionSafe that we've been through there. I think we've covered all the functions that we need to. So whereabouts is the vulnerability here? Because obviously this is going through and trying to parse and make sure that everything that we're entering is safe and it's not going to risk causing any malicious execution down here. So how are we going to get past these checks and still manage to inject some useful code? So the vulnerability here is actually with the isDictSafe function. So we're going to be wanting to pass a dictionary whenever we're doing this statement here, whenever we're passing in some input. But the reason being is we don't have any brackets here around the not. So you can see here if we highlight some of these, for example, if you go to and see the expression x and y first evaluates x, and if x is false, its value is returned, otherwise y is evaluated. So there's something to be careful about. It varies between different programming languages how statements like this are dealt with. In some languages you have it where if you have a series of statements, a series of conditions that are being tested, if the first condition comes back true or false, then none of the others will be tested. But essentially what's happening here is whenever we're running this if not statement, we're checking, it's going to call isExpressionSafe, and if isExpressionSafe comes back and says false, this would be true. Well, if the expression is safe, it will return true, and the not will inverse that to make it false. So it then would not bother even checking the second statement, so we're not actually checking to see whether the second expression is safe before we continue. So the correct way to have done this would have been to use parentheses around this statement. So we're actually checking isExpressionSafe for the k, for the keys, and then isExpressionSafe for the values in the dictionary. And then we're inversing the result. So if these come back true, then that will be inversed to false. Sorry, let me try and explain that again. I think I've said that wrong. So if we have these in brackets, this is checking if the keys, if this evaluates true and this evaluates true, that's the only way that this would return true. And then this is saying if that's not true, return false. So if we have brackets here, if either one of these returns false, then the AND condition isn't going to come back true, so it would return false, and then the not will basically mean that it returns to say it's not safe. Because we don't have those parentheses there, it's not going to do that. I'll probably explain that really badly. What I'm going to do is open up a write-up from the team that got blood on this in the HackTheBox University qualifiers, NightSec, and they put together a table here, a couple of tables which actually shows the results. So we can see some logic tables here. This is how it should be with the parentheses, and we can see then, depending whether these come back false, if they both come back false, it's unsafe. Basically, if any of them come back false, it's unsafe. The only time it should come back as safe, so unsafe is false, then is if they're both safe. Whereas what we have at the moment, the only way it's going to come back unsafe is if we have the false here and then true here. So in all the other three circumstances, we're going to get it saying that it's not unsafe and we can proceed. Note that if we have a look through this is a really good walkthrough anyway, which I'd recommend checking out, but if you have a look at the code here in terms of what the original challenge was, note that the one difference, I think this is the only difference that I noticed, was if we go down to the try statement here, what we had in the CTF was this statement, so the built-ins weren't being set to none, they weren't being emptied, and we didn't have this get attra being added. So the solution from that write-up doesn't work with this. We need to do something slightly different. So let's have a look and see how we can exploit this. So what I'm going to do is go and open up HackTricks, HackTricks PyJail. So we're basically in a Python sandbox here, right? And we want to try and escape it. So you have challenges like this called PyJails in capture the flag competitions. I'll leave up a couple of links at the end to some other videos where I've done some PyJail challenges in case anybody's interested. But if we go to HackTricks here, you can see we've got plenty of different options here on the right to check in. Note that we have some stuff here about built-ins and saying if we don't have built-ins, globals and locals, evaling Python code, so all stuff that's sounding pretty relevant to us. But let's have a look through and see just in general what we've got here. So we can see here command execution libraries. First thing you know, if you can directly execute code with some already imported library. So for example, as I was mentioning, if we already had the OS library being imported up here, we'd be able to just go ahead and access like system and call ls or getFlag.txt or something like that. In this case we don't, and we've also had the built-in stripped as well. We have some stuff here about pickling, again done some CTF walkthroughs on that as well. Evaling code, again this is interesting to us in terms of bypassing character filters and stuff like that. So you can see that hex is actually being used here. The 5f is replacing an underscore, which might be of interest to us. And then we have some mention of built-ins. If you can access built-ins objects, you can import libraries. So if we could access the built-ins library, that would be good. We could do something like this. In fact, let's go and run the, let's just take a look and see what this server actually looks like. Connect here with netcat. And okay, so we need to supply this as a dictionary. I'm going to create a new file, payloads.py, just so I get syntax highlighting and stuff in here as well. And we need a dictionary, obviously we're passing it in a dictionary. I'm just going to give it a number here, this is the key, and then we need to give it a value. So let's go and take our value as being this built-ins. We're not expecting this to work because of the underscores, but let's just go and try it out anyway. Paste that in and we get unsafe command detected, the snake approaches. So as expected, it's run through the function to see is expression safe, and well, in fact it didn't even get that far because it just called is safe, found that there was underscores in there, so we really can't use underscores. But if we go back now and say we want to replace those underscores with \x5f, which was the hex value for underscores, and go back and try that again, it still doesn't work. We get unexpected character after line continuation. So this isn't going to work for us because this is not being converted to a string here basically. So we will need to find another option. Let's go back to HackTricks. So it also tells us here what we can do if we don't have built-ins. If there are no built-ins, you're not going to be able to import anything, nor even read or write files. However, by default, Python import a lot of modules in memory. Modules may seem benign, but some of them import dangerous functionalities inside of them that can be gained access to and even remote arbitrary code execution. So we have some examples here, And some of this is going to be of interest to us. So we're accessing the class, the bases, and then subclasses. And you can see here this is the index 40. So essentially they've listed all of the subclasses, and then they found one of them which is of interest of type file, where there are functions within that file library like read, which will allow them to read files on the file system. So this is going to be of interest to us, but what we want to try and do is first of all list what we actually have here in terms of the class and the bases and the subclasses. We know we can't pass in these underscores, so we can't use this dot syntax, but we were given this access to this function called getAtch. So let's have a look at it. GetAtch, obviously get attribute. If we highlight that, and see it's going to get a named attribute from an object. So get x from y. So I'm going to try and get. So you can see that it's equivalent to x.y. And in this case, we're looking at like class.base. So this is going to give us an option to actually pass in this as a string, because that was the issue we're having here. We can't just pass in a string here that won't be interpreted as the actual library, but we can use get attribute to do something similar. So what we'll do here, we have the math function. That's the only library we have access to there. I'm going to change that to math, and then let's put in here. Let's take this and change this to class. And let's try and insert this here instead. So we need to pass it in as a dictionary still. That's looking good. Take a copy of that and paste that in, and you'll see this time it's coming back to say class module, which is great. So now we can kind of drill down into this a little bit more. We've got our bases here, and if we want to do this again, we're going to need to get another attribute. So let's go and just grab this here, get attribute, send this in, add another bracket here, and then so we're getting the attribute first of class, and then whatever was returned we're going to call get attribute again, and this time we're going to say base. And this can get a little bit confusing. Well, for me, I was, as you kind of building these up in layers, it can get a bit hard to track, especially if you like passing parameters to them or accessing list indexes and stuff. Let's change that to base. Let's run this again. And now we get class objects. That's still looking good. Let's do this one more time to try and get our subclasses. Copy and paste this, and subclasses, paste it again, and we have built-in method subclasses of type object, again looking good. What we need to do here then is pass that in as a function as well. Let me just add some brackets there at the end. Let's try that again, and this time it actually lists everything for us. So we're now listing all of those subclasses, and we can go and have a look at what indexes we actually have here. What I'm going to do is take this to, let's go and format this. If you have kind of formatting in your encodium, you could do it there, or you can go to something like I don't have it in my thing here. There's like a JSON stack viewer I normally use to format these. There we go. If we format that, and then we can go in. Has this got line numbers here? It does. Okay, so we can go and put this here. We can go and just make sure we've got our first subclass on the first line, so that we know what index it actually is. And then we can basically go and look through here to see if there's anything of interest. The first thing we probably want to do is search for OS and see, do we have any mentions of the OS library. You see here we've got OS wrap close, which is line 139. Since it starts at the index of 0, that's actually going to be 138. Which means we can now go over to our subclasses here and set this index to 138, and now we're actually loading that OS. Let me just go back and try that again. You see here OS wrap close, that's all looking good. From there we can move our way back to this OS library and call some other functions. Another thing to mention, if you're using something which auto formats, let me see if I hit Ctrl and S. Okay, it didn't at the moment, but once my lines get a certain length, it will move some of this down to the next line. And I was having some problems for a while where I was copying and pasting what was in here and not realizing because it inserted new lines that it was actually breaking the terminal output. So something worth bearing in mind. So at this point we could go back to our hack tricks and see where we can go from here. There are some payloads here. You can see built-ins, payloads, globals and locals. Let's try and see if they have an example of the one we're going to use here. This is also very good here. You see this if atch is present, which we have get atch, but if it's present you can access everything as a string, and it gives you kind of a general payload here which seems to work very regularly. It doesn't obviously work in this case. Even if you change that to get attribute, I guess we probably need some more syntax changes. We have just some options here about finding dangerous libraries, so you can loop in through subclasses and stuff like that as well. Recursive search of built-ins and globals. Okay, maybe it doesn't have the exact one here that I used. If we go back to this write-up from the HackTheBox uniquals, from here they called, so they accessed the same function, the only one that has OS, and then went to init, to globals, and then called system cat flag.txt. So to do that we'd need to add another couple of get attributes here for init and globals, and then we can just add our system cat flag.txt at the end. So let's go and grab this, and we'll take a copy of this, set that to init. We need one more, but let me just try and run that. Okay, it's saying it's missing a bracket. I've probably put one in the wrong place there. It's not looking good. Let's try it. Okay, there we go. It's got access to the init, which is good. We can insert another one here then, and this is now the globals that we want. Missing another bracket. I'm sure I keep inserting a bracket to deal with those, but okay, looking good again. So now again we could go and take this. In fact, let me grab a copy. Oh, there's quite a lot of stuff here. Some of this might be, let me just close this down and try it again. Just want to clear the terminal and take a copy of this. We'll just have a quick look at it in JSON stack viewer. Alright, yeah, there was a lot there. Take a copy and paste this, and again, depending on whatever library you're using here, you might want to go and see what's available. And this is showing all of our globals. Alright, yeah, there's a lot of stuff here. You can actually see some environment variables and things like that. IP addresses. Some functions here which might be of use, exec and stuff. Okay, but we've got everything that we need there. We just need to now try and access system. Which you can see right here. So this is all our OS functions, and system's going to be of most use to us, so we'll set this to system, and then to system we're passing cat flag.txt. You could pass something else here, so you could pass in ID, paste that in. Let me try that again. You can see we get back our ID, saying we're running as CTF. So we have execution. Let's try and do ls. We're able to list everything out there. We can see we've got our flag.txt, so we'll just go and say cat flag.txt, and we get back our flag. There's probably a lot of different ways to solve that. I mean, the only OS function we had access to there was this one at the index 138, but we could go down some other routes. For example, I saw that Clubby, who made this challenge, had put forward this solution. So going to math, accessing loader, is package, func, globals, and then just able to call built-in and stuff straight from there. So I did put that together as well with the same get attribute function. Let me just show that here. So it's a little bit longer, but it doesn't require that OS was available. So for example, in that case there, we had OS at 138, But if we didn't have an OS function, we wouldn't have been able to use that route. Now you'll see here, do you see how this has inserted these spaces? So I need to go and take those out. But if we take those out and copy and paste this and submit it, we get back our flag as well. So that's been the Tree of Danger challenge. Definitely check out this walkthrough by the team that got blood on it, because it's quite detailed, explains everything probably in a better way than I have in this video. And I'll put up some links here to some other challenges that I've done with Python jails in case you're interested in checking out more. Any questions or comments, leave them down below. Thanks.